So your final treasure map, if all goes well, has 7 vectors labeled so that if you were going on this hunt, you would know which way to go. 8 meters, 25 degrees, 2 meters, 210. There's arrowheads, and then you have your resultant. From where you start to where you finish, sketch that in, make it dotted because it's virtual. Label it resultant, measure to scale, give me size and direction. Problem is, lots of human error in terms of maybe not the size. You can use a ruler pretty easily. It's the angle usually you mess up. Okay? So today we're going to look at how do you actually calculate exactly, precisely what the final answer is. And you got to do a little trig. Okay? This is called precision pirating. There we go. We're going to go exactly to where the treasure is. We're going to beat Jack Sparrow at his own game. Okay? So to do that, we got to do a little trig. So to help you out, we're going to do a little speedy trig review. So in trigonometry, there are 3 basic trig functions: sine, cosine, tangent. And all they do is they relate the 2 sides of a triangle when you form an angle and break it into a right triangle. In fact, how about this? A little easier way to remember, okay? I think you guys have all learned this before in terms of a little quick trig review. In math class, there's this little politically incorrect acronym. It's called Chief what? You guys know? Chief SOHCAHTOA, okay? Chief SOHCAHTOA is actually from Illinois. He's related to the Illini, right? Just kidding. The great Chief SOHCAHTOA, Hau Kimosabi, we come in peace, okay? Chief SOHCAHTOA had a headdress made of feathers that were all right triangles. There we go. Except that looks weird. Chief SOHCAHTOA, whatever, right? I don't know how to draw that. So here's the basic idea. If you have any angle, let's call this theta, okay? You can turn that angle into a right triangle by dropping a perpendicular really quick, okay? If this side touches the angle, we call that the adjacent side. What do we call this other side then? The opposite side. And then this thing is the a squared plus b squared, the hippopotamus thingy. It's called the what? Hypotenuse, okay? What does S stand for? You guys remember? S is for sine. The sine of theta is simply equal to the ratio of the length of the opposite side over the adjacent side. What does cosine stand for? Did I write A over A? I did. Oh boy. It's going to be a long day. Opposite over hypotenuse. What is the cosine? The what? Adjacent over hypotenuse. And then finally, what's a tangent function? Opposite over adjacent, okay? And you're like, this is easy, Mr. Lau. Awesome. I want it to be easy for you, okay? So here's why we're going to use Chief SOHCAHTOA to make your life easier, okay? So we're going to do just one quick practice example here on this little worksheet here. Here's the idea, okay? What if I told you walk 5 blocks north and then walk 2 blocks north? How far did you go? Easy, right? 5 blocks north, 2 blocks north, 5 plus 2. It's like second grade math, right? How many blocks? Duh. 7 blocks. What if I said go 5 blocks north and then go 2 blocks at an angle of 47.8 degrees north of east? How far did you go? Is that easy to do? No, it's annoying, okay? So in real life, here's the idea. If you have vectors that just go north and south, east and west, in just the x, just the y, it's real easy. You just add them up, okay? So the problem is in real life, it's complicated. You have things going at weird angles. Are these vectors nice or are they like annoying? They're like what? They're annoying. They're at angles. What's with that? How dare you like drive at a weird angle or pull on a bridge at a weird angle? How dare you do that, right? Okay, but that's life, right? So here's a trick. You make it less annoying. Every vector can be simplified into 2 simple vectors, an x component and a y component. So here's what you do. You take your ruler, your straight edge, okay? If you still don't have your straight edge because you're slacking on me, you may use like your ID, no biggie, okay? Take it, lay it so that it touches the tip of the vector, and I want you to drop a perpendicular. So it's going to looky something like this, boom, till it hits the dotted line. Then construct a horizontal, okay? And here's the thing that is tricky, that messes up people, okay? I know this is basic trig. It's easy math for you guys. But we're not trying to do math. We're trying to do physics. We're trying to do real life. In real life, things have size and direction. Direction isn't important. By convention, we normally call going up north, going down south, going to the right east, right, etc. North, south, west, east, yeah? But let's keep our signs consistent. If you have a vector going up, let's make that positive, okay? Kind of like if you throw a ball up in the air, make that sucker positive. If it goes down, make it what? Negative. To the right, what? Positive, okay? And then to the left, negative. Why is that important? Because later on, when we add up a bunch of vectors, they might be going in opposite directions. And there's a big difference if you drive north versus south, if you support a bridge by having a support beam pushing to the east versus west. Don't want to mess that up, okay? For us, it's not a big deal. It's just a high school physics class. You miss a problem, no biggie. It's a lab, whatever, right? Tests you don't want to miss, but whatever, right? But in real life, if you mess up designing a bridge, okay, a support cable, whatever, that's bad because, it might fall apart. You might kill somebody. Not cool, okay? So details count. Got it? So in our first one, this is pretty easy. This one pulls in which general direction? North and what? North and to the right, east. So have it point north and east, okay? And we're going to break this into an x component and a y component. That's the trick, okay? And these are both going to be positive values. Why is that important? Because later on, like if you have a weird one, like, I don't know, number 8. Number 8's annoying. It's going south and west. You have a negative x component, negative y component, okay? But for now, let's just keep it simple. Let's take a look at breaking this down here. So if I have this angle in here, 41 degrees, I know the hypotenuse, this is a right angle. Which trig function can I use to find the x component? Okay? If the cosine of theta, oh, I gave it away. Okay, the cosine of theta, which is 41 degrees, is equal to the adjacent side x over the hypotenuse, 200, then the x is simply equal to 200 times the cosine of 41 degrees. Okay? Is that hard? Did I go too fast? It's basic trig, right? Should be easy for you guys. So get out your calculators. No way should you do this in your head. And really quick, common problem that we have is some of you guys are taking, crazy math class, hit the mode button. And a lot of times in math, you have radians selected. Not a problem. But in real life, most people use degrees just for navigation or building something because it's easier to communicate that to construction workers and boats and whatever, right? So make sure then that you hit the mode button and don't select radians, but hit enter to select degrees and then second quit out of there, okay? Got it? When you go back to math class, you can switch back, okay? So anyway, I'm going to get out of here, and I'm going to just punch in 200 times the cosine of 41, assuming I can use my calculator here. There we go. And we're getting a whopping 150.94, okay? 150.94, and N is just for newtons. A newton is a unit of force, named after Sir Isaac Newton. It's about 1/5 of a pound, roughly, okay? And I made that positive because notice, Zach, it's going which way? It's going to the right there, okay? How about y? How can we find y? This is easy, right? It'll just be 200 times the what? Instead of cosine, that's the opposite side, right? Sine of 41. So go ahead and punch that in really quick. We'll take 200 times the sine of 41. Piece of cake. And we're getting whatever, right? Like 131.2 newtons. Also positive, okay? And how can I check really quick that those two numbers are correct? This is a right triangle, right? So all I can do is do what? A squared plus b squared equals what? C squared. Or if I take the square root of 150.94 squared plus 131.21 squared, if all goes well, there we go, 199.9997, it's 200, okay? So, okay, hold on a second. Quick summary. What did we just do? That's actually absolutely brilliant. Here's what we did. We took an annoying vector, okay? It's 200 newtons at an angle of 41 degrees. Like, huh? That's weird. Okay, like let's say your car got stuck in the snow and we're trying to tow it out, okay? And you hook up a chain and you're trying to pull it. But in real life, it's like, it's like weird. It's like a weird angle. So all we do is we replace it with two simpler vectors. A force of 200 newtons at an angle of 41 degrees is the same as a force of 150.94 newtons pulling straight in the x direction to the right and 131.2 newtons straight up in the northwards direction. Okay? So the trick is every vector can be reduced to a simple x and y component. Okay? Yes, Coco, quick question. Go ahead. So let's look at a more complicated example. Okay? Flip over to the back side. Let's take a look at the back side. Whoa, what a mess. Okay? There we go. And actually, you know what? Why don't we not do the whole worksheet? Because it's not about doing the whole worksheet. It's about understanding here. Okay? So in real life, here's what's annoying. In real life, you drive a car, right? And you go whatever angle, whatever direction you want. How the heck do you know where you end up? Are these vectors nice or are they annoying? Which one? They are what? Annoying, because they're like, what? Like 25 meters at an angle of 35 degrees north of west, then 75 degrees, 20 meters at an angle of north of west also. Like, how far did you go? Like, I don't know. Like, leave me alone. I'm tired, okay? So here's the trick. Make it easy. Every vector can be simplified into an x and y. Then you just add up all the x's, all the y's. You can find your final resultant. Okay? Why don't we do one easy example? Why don't we do the second one? Let's do the second one here, okay? Just as a simple example here. So I'm going to clear this all off, and we'll just do this second one here, okay? So here's a trick. Let's take a look at this first vector here. Is it nice or annoying? Which one? It is annoying. Let's make it not so annoying. Let's break it down into an x and a y, right? An x and a y. And notice this vector goes what? North and what? West, right? North and west. Put on arrowheads because direction is extremely important, as some of you can attest, especially if you're holding your compass backwards, right? The other day. There we go. No V. So anyway, how can we find this? If this is the angle, this is the adjacent side, that's hypotenuse. X1 is just what? 25 times the what? Cosine, right? Of 35. Let's go ahead and try that really quick, okay? 25 times the cosine of 35. Get out your calculators. Let's chug this through. Give me the x and y component, okay? 25 times the cosine of 35 degrees. I'm getting 20.47. And look what I'm going to do that's kind of tricky. I'm going to add a negative in front. Negative 20.48. Okay? Negative 20.48 meters. Why negative? Because it's going which way? To the left. Is that important? It is, because you might go, to the right and then to the left, right? You just got to be consistent depending on the problem there. Or you might go down and then up, okay? And then y1, we can do the same thing, except instead of doing cosine, I'm going to do what? I'm going to do sine, okay? I'm just going to do this in the blue. And it's going to be positive because I know it's going up. So if I punch that in really quick, I take 25 times the sine of 35, okay? And I'm getting a positive 14.34 meters, okay? 14.34 meters. Why positive? Because I'm going which way? Up, okay? Next, I want you to do the same thing, but now do it for the second vector, okay? So break this sucker up into a y component. And notice the second one, it's going more up than it is, it's going more north than it is going west. You see that? Because it's at an angle of 75 degrees. That's all, okay? And again, no headless vectors. It's very important that you put an arrowhead on there so you know which way you're going, okay? And you guys are so fast with your calculators. Someone already have x2 and y2 for me? You guys are awesome. What did you guys get for x2 and y2? Someone already have that? And then x2 is in here. Is x2? Okay, negative 5.17 meters. And all you did was you took 20 times the cosine of 75, right? And then how about y2? 19.3 meters. Awesome. Okay? And you know what? If you round a little bit differently, I'm okay with that. Okay? Now what? Here's how you finish. It's real easy. Okay? It's really annoying to tell somebody, hey, you want $10,000? I buried it out in the field. Okay? Start at the tombstone. Go 25 meters, 35 degrees north of west. Then go 20 meters, 75 degrees north of west. Good luck, right? And they don't have a compass. They don't have a meter stick. They're in trouble. Here's what you do instead. You can say, instead, go straight west, x total. How can you get x total? You just add up what? x1 and x2, right? So add up 5.17 and 20.48. Punch that in. And it's negative because all it is we're going which way? To the west. Okay, so what do you get when you punch that in? Negative. I can't do that in my head. Help me out. 25.66 meters. Thank you. And then how can you get y total? Same thing, right? Add up y1 plus y2. So what do you get when you add up 14.34 meters and 19.3 meters? I apologize for my lefty chicken scratch on a screen at a weird angle. There we go. What do you get? Anyone else lefty? Woo! We're in our right minds, right? Everyone else is crazy. Yes! Yay! You're lefty. You're lefty. Awesome. Good. What do you get when you punch it in? 33.6 meters. Good. Okay? Now we're not done yet. We're almost done because all we did was we found the total x and the total y. But notice this is a lot easier. I could tell somebody, if you want to get $10,000, go out to the courtyard, start at the sewer grate where Captain Redbeard is buried. Go 25.66 meters straight west, and then go 33.6 meters straight north, right? And that's very doable, right? But really, we want to get the final answer. How do you get your final resultant? Let me do this in a different color, okay? I'm going to clean this up a little bit now. Don't worry, okay? Your final answer is pretty easy. It's always from where you what? Start to where you what? End up, okay? This is the resultant. It looky something like this. Okay, I'm going to make it dotted. It's a virtual vector. Okay. Let me label this puppy R. R is for resultant. And notice if we do our y total, this is our y total right here, and our x total like this, right? We can get our resultant. And this is a right angle. So how can I get my resultant? A squared plus b squared is equal to what? C squared. So if I just do my x total squared plus my y total squared, and then I take the square root of that whole sucker, I'll get my total resultant. Okay? So take 25.66 squared plus 33.6 squared, take the square root. And when you do that, survey says, someone got that? You guys are faster than me, than my virtual calculator. There we go. Nick, you got that? 42.3 meters. Good job. And we're not done, because all vectors have what? Size and direction. Oh, this is killing me. It's so painful. We can do it, okay? We can find the angle. So which angle do you want to find? If I know x total and y total, why don't we use this angle in here, okay? So I could do the inverse tangent function of opposite over adjacent. So in this case, if I do the inverse tangent, okay, you just hit second tangent for inverse tangent, or the arctangent there, of my opposite side, that's the x total, 25.66, don't worry about the negative, okay, divided by 33.6. We only need the magnitude of the vector there. I'm getting this to be an angle of 37.4 degrees, okay, good enough. This angle in here is 37.4 degrees. You see that? So to write down that angle, my final answer, it's 37.4 degrees, and looks like it's west of north. Or I could subtract that from 360 to reference it from 0 degrees. Okay? So in other words, instead of saying go 25 meters, 35 degrees north of west, 75 degrees north of west, 20 meters, I could just say go exactly 42.3 meters at an angle of 37.4 degrees west of north. There we go, my lefty chicken scratch. And you will find the treasure. Dig a hole 3 feet deep, you'll get $10,000. Just give me, 10% cut. No problem. Got it? That is the vector method, the component method of